Mass spectrometry presented by science visualized. Mass spectrometry is also called MS. Mass spectrometry is a method that helps to determine the following. Number one, it can give the molecular weight and the size of the compound. Large molecular weight will mean something is much bigger, like say a polymer. A smaller molecular weight will mean a smaller molecule. Mass spectrometry also gives molecular formula by using the exact mass when you use what's called a double focusing instrument. Some key points about mass spectrometry. Number one, molecular ion or molecular peak. Ion and peak are used interchangeably, which is also called M plus peak or M plus ion, also called the parent ion or parent peak. This is the unfragmented radical ion that gives the molecular weight. It's usually the farthest to the right. So if you have a mass spectrum like this, and then you have the peaks, the farthest to the right is most likely going to be the M plus peak, and that will give the molecular weight. Remember, the units is M over Z, and the y-axis is percentage abundance. The base peak. This is the tallest peak. It has 100% intensity. So when you have a mass spectrum like that, and here is the percentage abundance again, the tallest that goes to 100% will be the base peak of the base ion. M over Z means mass to charge ratio, and that's the unit that's used for x-axis. That actually correlates to the molecular weight or the mass of the fragment. Please review my video on how mass spectrometer works. Let's continue. This here is an example of a mass spectrum. On the x-axis, you have M over Z, so increases that way. On the y-axis, we have the percentage abundance up to 100%. And then the peaks appear like lines. The farthest to the right is going to be the molecular ion or the M plus peak. So in this case, M over Z equals to 61. The tallest peak, this one here, is going to be the base peak. In this case, M over Z equals to 29. See, it's just before 30. And we see one of the fragments here where M over Z equals to 15, and that corresponds to CH3 ion. We know the mass of carbon is 12. The mass of 3 hydrogens is 3. So 12 plus 3 equals to 15, and that gives that peak. The fragmentation pattern. This is very important in mass spectrometry because it shows how the molecule breaks apart into smaller fragments or sizes. Each of them has a different M over Z value. This information is used to generate the structure. So for example, if you see the M over Z equals to 15, that will mean you have the molecule contains a CH3. Common fragmentation patterns. If you see a peak with an M over Z value of 15, that will mean you have a CH3 fragment. So that shows that the molecule contains a CH3 group. And the reason it comes to 15 is because carbon has a mass of 12. Each hydrogen has a mass of 1 times 3 hydrogens, and that gives 12 plus 3, which equals to 15. An M over Z value of 17 means that the molecule contains OH group. The mass of oxygen is 16 plus that of hydrogen 1 gives you 17. Also, molecules that contain OH group, like alcohols, can lose water, so they can lose H2O. And when that happens, you see a mass of minus 18 because hydrogen is 2 plus 16 gives you 18. Another important peak is 29. 29 basically means that you have a CH3 and a CH2 group. So when that breaks off, you end up with 29. So CH3 is 15 plus CH2. Remember, carbon is 12 plus 2 hydrogens. That makes 14. So the total becomes 29. So it means 2 carbons. An M over Z value of 43 shows that you have 3 carbons. So it could be CH3, CH2, CH2 in that order. Or it could be the substitution at this position, the second carbon. So CH3, CH, and then CH3. If you add, all of them will give you 43. So these two are like isomers. They have the same molecular formula but different structures. An M/Z value of 57 means that you have 4 carbons, 4 alkane carbons. So that could be CH3, CH2, CH2, CH2. Remember, that's 15 plus 14 plus 14 plus 14, and that gives 57. Or you could have the substitution, instead of it being at this terminal position, it could be at the second carbon here. Or you could have an isomer like this one. Next, M/Z value of 77 means you have a benzene ring. So one part of the carbon doesn't have a hydrogen because it's connected to something else. That means you have 12 there for only one carbon, a mass of 12. And then each of the other carbons, each of them has a hydrogen. So, for example, that one will have carbon plus hydrogen, which is 12 plus 1, which equals to 13. So you have 13 all through. So 13 times 5 plus 12 gives you 77. Anytime you see 77, it means the structure contains a benzene ring. An M/Z value of 91 will mean that you have 77, which we know is benzene ring, plus 14 for CH2, and that gives you 91. Another important, M/Z equals to 105, and that's basically benzene ring plus a carbonyl connected to something else. The carbon here has a mass of 12, oxygen has a mass of 16, then plus 77.